everybody. Hope everyone's doing well. Every week I'm going to be making a video lesson for you, kind of like if we were actually in class, going through how we do everything with the new stuff, so you have examples. The expectation is you are taking notes on this. One of your grades will be that you will submit the notes that you took. So you don't have to write down the problem. You don't need to write down these tables that you see right now, but you should be writing down the stuff that I am writing down. So that way I know that you're actually watching this and you're trying to follow along what I'm going through. One of the problems we're going to run into with however long we have to do this is that you don't have calculators that we are used to working with. So what I'm going to do is try and show you how you can use technology such as anything on the web to go through all the math. So I will not be using a TI-84 for any of this. I will only be using web-based things that I will leave links for to show you how you can do all the math. Unfortunately for us, this is a little more mathematically intensive than some of the other stuff we were doing, but I will show you how we can get through all that, and hopefully it won't be too horrible. If you have any questions, please feel free to either leave something on the team, send me a message on Remind. I will be posting office hours at some point, and I will share that with you also on the team group. Without any further ado, let's go ahead and get started by looking at the first problem that we have here. So it says a retail trade association claims that the tax preparation methods of adults are distributed as shown on the previous page, which is right in front of us. A tax preparation company randomly selects 300 adults and asks them how they prepare their taxes. At a significance level 0.05, which remember is alpha, that's the association's claim. So this is unlike anything that we have ever done before. Okay, it's a completely different type of test that we have to do. But luckily, the basic steps are all the same, just like we've been doing for the past, feels like forever. So you don't need to worry too much. We're not doing something 100% brand new, but there are definitely going to be some bigger changes on this one than what we have seen in the past. Okay. So what this is going to be requiring us to do, okay, we're going to be doing a chi-square. I am writing with a stylus. So I apologize. Chi-square goodness of fit test. It is a very weird name. Grammatically, it's not correct. It should not be goodness of fit, but that is what it's called. Chi-square goodness of fit test. The symbol for chi-square, which we're going to be using, looks something like that. So that is the chi-square symbol. Okay, so that is what we are going to be, our test instead of P or Z, we are going to be calculating chi-square. So that's where we're headed here. Okay, so I'm going to clear this out. Remember, anytime you can pause the video. If you need to write something down, or you can always go back if you missed something. One of the joys of having a video instead of just real life. Okay. So the first thing for any hypothesis test is that we need to write our null alternative. Unfortunately, the null alternative are not going to, or maybe fortunately, I don't know, are not something that is going to involve symbols. So the first step that we usually did was define the parameter. For chi-square, there is no parameter. We're not going to be defining a parameter. We're just going to be going straight to HOHA. So your null and alternative hypotheses are always going to be written in words for this, not with symbols. Okay. So for this specific example, our null hypothesis is going to be that. So we always want to read the problem. Essentially what we're going to write is that whatever the problem is about matches the given distribution. So when we read through the problem, the question is talking about tax preparation methods for adults. So our null hypothesis is going to be the distribution of tax preparation Trust me, that says preparation methods of adults. So there's our context, and then we say matches the given distribution. Okay, so our original assumption is that it actually matches what they're claiming. So what does that mean? That means that 24% of people use an accountant, 20% of people do the taxes by hand, 35% use computer software, 6% use family friendly, and 50% use tax preparation services. So that's what that sentence is trying to say. And that is much quicker than saying that accountant is 24%, by hand is 20%. So that's why we write HO in words. It's much faster instead of defining all these different parameters and all that jazz. So null hypothesis for this type of problem will always be the distribution of whatever matches the given distribution. So then HA, and it's not like you can really read what I'm writing anyways, but I will try and write it, is always that the distribution does not match. So the distribution of tax preparation methods of adults does not match the given distribution. And we are done with step one. So HO is always the distribution matches. HA will always be the distribution does not match the given one. So meaning that at least one of them is off. Okay, so we are done with step one. HO and HA is done. So after HOHA, we move on to our test statistic. Okay, so this test only has 5 steps because we take out the parameter step. However, the next step can take a little bit of time. So the test statistic is arguably one of the longest to actually calculate, unfortunately for us. So I'm going to erase this. If you need to write down, pause it or go back, but I want the room here. So let me erase this. So what I'm going to do is I'm going to write down the formula for chi-square. And we're going to go through how we come up with all those numbers. And then I will show you how we can use just simply the calculator that Google has to calculate it. And then we'll go from there. All right. So our chi-square statistic is calculated in the following way. So chi-square is equal to the observed minus the expected squared divided by the expected. And then we take the summation of that. So for each of our numbers, so the accountant by hand, computer, software, so on, we'll have a little fraction, and then we add all of those fractions together to get the chi-square. So for this first problem, I am going to write out every single fraction, but in the future, I will just write out the first and the last, because at that point, you should be seeing the pattern. So these right here are our observes. Okay, the 61, the 42, the 112, these are all the observed values. So for every one of our fractions, the 5 fractions we're going to make, these numbers right here are going to be the first number in the fraction. The thing that we need to figure out then is the expected value. So that is where this table here is going to come into play. We're going to use this table here for the expecteds. Now, these are not the expecteds, okay? These are what percentages they should be. So be aware of that. If you're using decimals like 0.24, 0.2, 0.35 as your expecteds, you are going to get chi-square values that are ridiculously large, and it is wrong. So first thing I'm going to do after now we know where the observes are is we need to find each of the expecteds. So to find the expected, the first thing you need to do is figure out the total. Okay. Now, obviously, this example has told me the total is 300. Now, if they don't tell you what the total is, you would have to add those up. So I'd have to take 61 plus 42 plus whatever to figure out the total myself. So I don't think every problem tells you the total. In fact, I'm pretty sure I made some that do not. So you will have to add those up yourself. So now that I have the total of 300, the next step is I need to multiply each percent by the 300. Okay, so increase this. We know the total is 300, so there we go. So the first thing I'm going to do is look at the accountant. So I know there are 300 people. I know that 24% of them are supposed to use their taxes, do their taxes by accountant. So I'm going to take 300 times 0.24. Okay. Now I can go to just simple Google calculator. If you literally Google calculator, then you will get this. So I can do 300 times 0.24, and the answer is 72. That's a pretty simple method. So the expected for that is 72. So what I'm going to do is I'm going to go down here and start all my fractions. Okay. For my first one, I have the observed, which is 61. I have the expected, which is 72, and that is literally all that's in the formula. So I square is going to be equal to 61 minus 72 squared divided by 72. So you'll notice that the numbers right here are always going to be the exact same. So once you have that one in the top right, just plop it on the bottom every time and it will be good. Now remember, I said we have to do this for every single one. That's what that squiggly sigma is doing right here. That means add a bunch of crap up. So, okay, apparently. So I'm going to have a plus. And now I need to do that for by hand. Okay, so I already have the observed by hand. The observed by hand is 42. I need to find the expected by hand. So remember, we take the total, which is 300, multiply by the percent of by hand, which is 20%. And that, you can go to your Google calculator if you want, but 3 times 2 is 6. Move the decimal place, should be 60 is my guess. Let's just double check because I could be wrong, but I highly doubt it. And sure enough, it is indeed 60. So next I have to do the observed. So my observed was 42. 42 by hand. I'm expecting 60. So we do 42 minus 60 squared divided by 60. And we just do it again. So I can probably squeeze one more here on this line. So now that I've kind of done it twice, I'm going to go a little bit faster here. So now we're doing computer software. So I'm going to take my 300 times 0.35, which I don't feel like doing in my head. So let's do 300 times 0.35, and I get 105. So the expected is 105, and we go down here and do it again. The observed was 112. Okay, so we do 112 minus 105 squared divided by 105 plus, and I have 2 more fractions to go. Friend family. So let's get rid of this. For friend family, it's going to be 300 because that's my total. Multiply by 0.06, not 0.6. It could be 18, but let's double check. 0.06. Sure enough is 18. So then 29. So we do, extend my page. So we do 29 minus 18 squared divided by 18, and we are almost done. Plus, last one we have is tax preparation service. So then we need to do 300 times 0.15. I think you guys are seeing the pattern here. So 300, oops, times 0.15 is 45. And we're done with the kind of tedious part, I guess. We have all the math ready to go. So 45, 56 minus 45 is going to be my fraction for this one. So 56 minus 45 squared divided by 45. Okay, so that is how we get chi-squared. Now, the fun part, we have to actually do that. So we need to type all of this in to the calculator. Now, the Google calculator will do this just fine. You don't need to do anything fancy here. The problem is I probably should have written this down. So I'm going to kind of do this, so that way we can all see kind of what's going on. Okay. And I need to type this part in here. Okay, all of this stuff. So I'm going to do that right now. So first we have parenthesis 61 minus 72 parenthesis. Your squared button is right here. You can see me kind of like I touched it. It says x to the y. It's right next to 0. 2. And then divided by 72. You can enter there if you want. And then just keep doing each one, but I'm going to go ahead and keep going. So plus parenthesis 42 minus 60 parenthesis x to the y squared divided by 60. I'm using a stylus for this. I'm not using a keyboard, so you can easily just use your finger like I am using my stylus. Plus parenthesis 112 minus 105 parenthesis squared. I don't know why I blanked out there. Divided by 105 plus parenthesis 29 minus 18 parenthesis squared divided by 18 plus parenthesis 56 minus 45 parenthesis squared divided by 45. And that is our 5 fractions. So all I have to do now is hit equals. And our chi-squared is 16.958. All right, we pretty much did the math hard part, okay? It's not hard math. There's nothing difficult really about any of the math I did. I'm there's doing it all anyways. But that is what you're going to have to do if you don't have a TI. If you have a TI, there are some shortcuts you can take. I'm not planning on going over that because most of you do not. It doesn't save you that much time, just takes away a little bit of the tedious work you have to do. So the value is 16.958. So 16.958 is my squared value. Okay, so all we need now is our p-value and our conclusion, and we are done. I will end the video there. I will do one more video of an example, but I didn't want them both to be I didn't want this to be like a 40-minute video. I wanted to do it in little chunks for you. So now we need to find our p-value. Now we don't have an alternative, so how do I know if it's greater, less than? Is it a two-tailed test? Well, you're in luck because chi-square is always a greater than. Chi-square is always an upper-tailed test. There is no anything else. There's no doubling the p-value. There's no figuring out is it less or greater. Excuse me. It is always going to be greater. Now, like the t-model, chi-square also has degrees of freedom. Now, it is not the sample size minus 1. It is not n minus 1. So let's write down how to find df. It's very easy. Okay. I don't know why it's producing it. So df, degrees of freedom, is equal to the number of categories That's minus 1. So number of categories minus 1. So what does that mean by number of categories? So we go up here. Okay. Number of categories is how many actual classifications do you have? So let's see. You have 1, 2, 3, 4, 5. There are 5 different categories. You have accountant by hand, computer software, friend, family, tax preparation. There are 5 categories. So therefore, the DF is going to be equal to 5 minus 1, which is 4. So we get 4 degrees of freedom. Do not do 300 minus 1. Your p-value will be way off. You have to do the number of categories minus 1. Okay. So I'm going to erase this. So number of categories is minus 1. Hopefully you wrote that down. All right. So we're going to find the probability that chi-square sub 4 is greater than 16.958. It will always be greater than, so you don't have to worry about that. Okay. Now the next thing you need is a p-value calculator, which I have found one that is perfect. It's very easy to use, and what we will be using. I will post the link of the p-value calculator in Teams. All you do is click on that link. It'll take you right to the website. So it'll look something like this. So you'll notice on the very top, it says chi-square value and it says degrees of freedom new, which you don't need to worry about the new. There's side B, but it's actually pronounced new. So I need to use my keyboard here. So my chi-square value was 16.958. And degrees of freedom was 4. You hit calculate. And there you go. There's your p-value. It's even showing you a graph. If you were wondering what chi-square looked like, it's right here. Okay. Right here. I don't know if you can see this little dots popping up, but that's the chi-square graph. You'll see it's kind of skewed to the right, but there you go. But our p-value, you'll see is 0.00197. Okay, 0.00197. And we have done all the math part. The math is done. So our alpha, or our significance level, was 0.05. And our p-value is definitely less than 0.05. So remember, when your p-value is less than alpha, you reject HO. I think I'm going to type this so you can actually read it. So since, I also spelled since wrong. Let's do 26. So since my p-value is less than alpha, I reject HO. Okay. Remember, when your p-value is less than alpha, you reject HO. So there's your first sentence. And remember, the second sentence is there either is or is not evidence of HA. So I need to say there is evidence that, I erased HA, but you have on your paper. Okay, so there is evidence that the distribution of, I forgot what it was, you guys who just, tax preparation methods of adults. Distribution of tax preparations of adults does not, okay, does not. Remember, your alternative is not. So do not put it does match. You have evidence that it does not match. Does not match the given distribution. So what that is saying, I spelled distribution wrong. Okay. Oh, I spelled reject wrong too. There you go. Perfect. Okay. So what that is saying is that we have evidence that at least one of these does not match. Now, I don't know if accountant's not the 24%, if the by hand's not the 20%. The test doesn't tell you that. All the test is saying that at least one of these methods, accountant by hand computer software, is not matching the given percents on the left. It's not matching the 24, the 20, the 35. You don't know where, but somewhere it's off. Somewhere this distribution that we have right here, okay, is not matching what we actually see. We have evidence that whatever they said here on this part here is wrong. And that's it. That is the chi-square goodness of fit test. So I know there's a lot of math going on with the fractions and coming up with that. But to recap, Remember, HO and HA are done in words. Okay, I don't have them here. I probably should have left them, but I have them. Your chi-square value, you take the observed minus the expected squared divided by the expected for each category. You add all of those up. Remember, to find the expected, you just take n times the percent. Okay? Make sure that percent's a decimal, though. That's all it is. So we did 300 times 0.24, 300 times 0.2, 300 times 0.35. Added all those up. Got 60.958. Remember, degrees of freedom is categories minus 1. It is always greater. Okay? It is always greater than, right here. Always use a greater than symbol. And then use that p-value calculator we talked about, where you put your degrees of freedom and your chi-square value in, hit calculate, you'll have it. And then the same thing applies with our conclusion we've written a million times. It should be really easy to do the conclusion now because you've already written the alternative in words. And you literally have written the alternative in words. You just copy that down. There is evidence, is the only part that you have to think about. There is evidence that the distribution of tax preparations of adults does not match the given distribution. If for some reason my p-value is big, the only thing that would have changed is I would have said there is no evidence that the distribution of tax preparation of adults does not match the given distribution. All right, so we did cover a lot here in this video. I am going to end it here. If you have any questions, once again, you can post something on the team. You can send me a message on Remind. I would not recommend email, but you could email me. I don't get notifications for that on my phone, so I don't get it right away. But please, if you have any questions about anything, go ahead and send me a message. All right, I hope this is helpful for you and helps you learn what's going on here. And I will make one more example that's a little bit different than this, but I wanted to end the video here.